Welcome friends to another video. I am your professor Divyajyoti Bhattacharjee from the Department of Statistics, Assam University, Silchar, and we will be today studying more about random variable and mathematical expectation. If you have watched my previous video, you must have noticed that in that video we had discussed about random variable. We have looked into different definitions of random variable. Then we introduced the concept of mathematical expectation and variance of a random variable. And then we have actually notified different theorems which were concerning mathematical expectation of random variable, its variance, etc. So in this video, we will go a step forward and we will use those definitions and theorems learned in our previous video for solving different problems concerning random variable and mathematical expectation. So the first illustration tells that three fair die are thrown. Find the expected value of the sum of points in them. So first we understand what is a die. We already know. Then we know that if a die is thrown, then there are six phases. So which actually turn up, any one of them will turn up. So suppose this is a die, and so let x be a random variable which represents the outcome of a die throw. So we know that if a die is thrown, then the outcome is concerned. We get actually 1, 2, 3, 4, 5, 6. So these are the six values. And what is the corresponding probability? 1 will appear with a probability of 1 by 6. 2 will appear with a probability of 1 by 6. 3 will appear with a probability of 1 by 6. In this way, 6 will also appear with a probability of 1 by 6. 1 by 6. So let x, we start the experiment. Let x be a random variable, be a random variable which represents the outcome of the first die, of the first die. So if we look at the expectation of x, so expectation of x is equal to, if you go by the formula, summation of pi into xi. So first one is xi value is 1 multiplied by 1 multiplied by 1 by 6 plus 2, that is also multiplied by 1 by 6 plus dot dot dot. We go to 6 terms, and that is 6 into 1 by 6. So if we take 1 by 6 common, then we have the sum of first 6 natural numbers, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that sum comes out to be equal to so 1 2 3 4 sums up to 10, 15, and then it comes up to 21. So we have this as 21 divided by or multiplied by 1 by 6, that is 21 by 6, and that gives a value of how much? 3.5. So this is the expected value of the first die. So let y and z represents the outcome, represents the outcome of the outcome of the second and third die. Second and uh, third dice. So what we have to find the expected value. So we have to find the expected value of x plus y plus z. So the expected value of x plus y plus z is equal to expectation of x plus expectation of y, because we have a theorem related to that, plus expectation of z. Now you see, expectation of x we have also already computed, and it's 3.5. Now expectation of y and expectation of z, they also will be 3.5 each, because they are the same experiment repeated once again. So expectation of y will also be 3.5, and expectation of z will also be 3.5. So ultimately these, sorry, not 3.7, 3.5. So ultimately these will be 10.5. So the expected value of the sum of points in 3 die thrown together is 10.5. So this is how we solve the first illustration. We now go to the second illustration. In second illustration, let us read the question. Let x be a random variable having a probability distribution x equal to 0, 1, 2 and 3 with corresponding probability 1/3. half, 0 and 1 by 6 respectively. Find the expectation of x, expectation of x square, expectation of x minus 1 whole square, and then variance of x. Okay, then let us first write whatever we have. Let us write the density distribution of x. So here we use this space so that our computing arena remains relatively free. 1 and 2 and 3. And corresponding probability, we write it like this: probability of x equal to small x, and then this is equal to, first one is 1/3, second one is half, third one is 0, and the fourth one is 1 by 6. 1 by 6. Now what happens here? First we start with the expectation of x. So we start here, expectation of x. So always write the formula when you compute. So this is a discrete random variable. So I have the formula as summation pi into xi. So here we have pi is 1/3, first value, multiplied by 0, plus second value is half. So we write 1 by 2 multiplied by 1, plus third value is 0, probability is 0, into 2, plus next value is plus 1 by 6 into 3. Now here you see some terms get cancelled because you have multiplication by 0 here. Here you have multiplication by 0. Here also you have a multiplication by 0. So these two terms does not contribute. So second term gives you half, and the fourth term and gives you once again half. So half plus half equal to 1. So expected value of x is 1. So we have reached this. Now let us compute expectation of x square. Expectation of x square. So expectation of x square, this is equal to summation pi probability into xi square. Here you see we are using the formula expectation of gx. Here gx equal to x square. So exactly the function will be replicated here. Probability will remain the same. So first one is 1/3 into 0 square plus look here, you will understand better than looking at the question. So the x value is 0, probability is 1/3. Probability will remain same, the value of x will only be squared up. So next one, probability is half multiplied by 1 square. Next one is probability is 0 multiplied by 2 square. Next one is probability of is 1 by 6 multiplied by 3 square. So 3 square is equal to 9. So this is equal to first term does not contribute, and the third term also does not contribute. Second term gives you half, and third terms give you 9 by 6. 3 square is 9. 9 by 6. So 9 by 6 is 3 by 2. So ultimately this gives you 4 by 2, that is equal to 2. So expectation of x square is 2. Now let us look at this expectation of x minus expectation of x minus 1 whole square. We can use the formula as that of previous one. But there is another way of looking at it because many values we have already computed. Let us break it, x minus 1 whole square formula. So that gives me x square minus 2x plus 1. So this is equal to expectation of x square minus 2i's expectation of x plus expectation of 1 is 1, because expectation of a constant is the constant itself. So this is the thing. Now you see many things we have already computed earlier. Expectation of x square is 2. Let me replace the value, minus 2 into expectation of x is 1. So this is 1 plus 1. So this gives me equal to 1, because this is also middle term is 2. So minus 2. So minus 2 plus 2 and then plus 1. So this is expectation of x square. Lastly, we are to compute the variance of x. So we come here, we compute the variance of x, and the formula, the computational formula, as you know, it is expectation of x square minus expectation of x whole square. This is the computational formula which we use. I told in my previous video that this formula is commonly used for computation. Now expectation of x square, already we have seen expectation of x square is 2 and expectation of x is 1. So 1 square is once again 1. So that is 2 minus 1 equal to 1. So we have variance of x as 1. We have expectation of x minus 1 whole square as 1. Then we have expectation of x square as 2, and expectation of x is 1. So these are the answer to the particular problem. Now let us look at the problem number 3, that is illustration 3. A trader, means share market trader, wants to choose between two stocks by tossing a coin. He chooses stock A if head appears and gains 10 units of money at the day's closing. Inversely, if he invests stock B, he loses 3 units. He invests twice using the same rule. Find the expected earning and also find the variance. So like the previous case where we had three dice were thrown, here also this experiment is repeated twice. The rules remains the same. Now stock A or stock B is not important. Let us see what are the values of X. Let X be a random variable which represents his earning. So you look at this, if he stock A, then he gains 10 units of money. That means X gets plus 10. Okay. And if he chooses stock B, at the end of the day, he loses 3 units of money. So this is 3. So this is what is happening. And then the probability, let us check what are his probability. So his probability is like he is deciding whether to invest in stock A. This is what he gets from stock A. And this is what he gets from stock B. Stock B. So this is actually he gets from stock A and stock B. So in stock A, he gets 10 units of money, and whether to go with stock A or to go with stock B, that is technically decided by tossing of a coin. So when he tosses a coin, if a head appears, then he goes with stock A. So probability of head, assuming that the coin is fair, is half. And probability that he goes with stock B when a tail appears, assuming that the coin is fair, is also half. So these are the probabilities and these are the corresponding values of X. Now, once we understand the problem, let us start writing. Let X be a random variable which represents the earning of the trader at day end. So, by the question, so by the question, the probability mass function or probability distribution is as follows. And then you write these values x like x 10, x takes the values 10 plus 10 or minus 3. This is with probability half and that is also with probability half. Now expectation of x, this is equal to half into 10 plus half into minus 3. Yeah, it is better to write the formula always. So you may write the formula before writing this pi into xi. Okay. So this gives me, first gives me 5 and second ones give me minus 3 by 2. So if you take the LCM, you'll have 2 and then this is 10 minus 3 equal to 7 by 2 equal to 3.5. 3.5. So this is expectation of x. Now, for two tosses, means he plays in the same rule twice. So first day let x be the random variable day, second day be y. Now, if the earning in the second day is represented by the random variable y, then expectation of y is equal to 3.5 since the rule since the rule is same. Rule is same. So his earning of in 2 days is equal to expectation of x plus expectation of y is equal to, this is expectation of x plus expectation of y is equal to 3.5 plus 3.5 equal to 7. Okay. So this is how this problem goes on forward. Now we have to also to compute the variance. So let me create some space by rubbing some parts of this. Okay. We'll have some parts. We create some space for computing the variance. So first we'll compute the variance for 1 day and then we'll just multiply it by 2 or just add the same thing once again to get the random variable variance for the random variable y to be added with the variance of the random variable x. Okay, now coming back to the problem, let me pick up a pen. Let me pick up in a yellow colored pen. So expectation of, sorry, now variance of x is equal to expectation of x minus expectation of x whole square. Okay, let me pick up a black pen because otherwise contrast is not properly created. Okay, now so first we need to compute expectation of x square, because in this expression, previous expression, we know sorry, x, this is expression of x square minus expectation of x whole square. Expectation of x we know. So expectation of x whole square I can create. What I need to compute is expectation of x square. So that is equal to, so formula is summation x square by xi square by pi multiplied into pi. So okay, so pi xi square or xi square pi products are commutative. So first one, you see probability is half. So p remains the same. Xi square 10, it's 10 square. 10 square is 100. Then plus next one is half multiplied by minus 3 square. So minus 3 square is 9. Okay. So this is what we have. So we have 109 by 2. This is equal to 54.5. So 54.5. So that is expectation of x square. Now we have, so variance of x equal to expectation of x square minus expectation of x whole square, so that we can write here as this is equal to 54.5, and a minus expectation of x we have computed as 3.5, so it is like 3.5 square. So this is equal to 54.5, and then we have 3.5 square. This is 12.25. Okay, so 12.25. So accordingly, if we subtract, then we get this as 42.25. So this is the variance of x. Now, if we play the game twice, and each time the game is independent of each other, because stock, we assume that stock in the first day is not the same, is independent of the outcome of the stock in the second day, then we have variance of x plus y equal to variance of x plus variance of y. There is a covariance term also, but since x and y are independent, so we shall not consider the covariance term. So this is 42.25, 42.25 plus, again we have 42.25 for second day, same value, because the rule is same, other values are all same. So this we have 84.5. So 84.5. So this is the corresponding variance. So this way we solve this particular problem. Now let us look at the next problem. So here we are given a discrete probability distribution. So let us write the probability distribution and then we proceed forward. So here we have x. X is taking the value 0. It is taking the value 1. It is taking the value 2. It is taking the value 3 and 4. And we have also the corresponding probabilities. So probability of x equal to x. This is equal to, this is k. This is thrice k. This is 0.2, this is k, and this is twice k plus 0.1. So these are the, we have the probabilities. Now, first we need to find the value of k, because unless we find the value of k, we cannot get into the perfect probability distribution and we cannot compute the expectation and other things. So let us start this problem. Like we know that, we know that that the total probability, that is summation of probability of x equal to x, that is summation, this is equal to 1. So this implies that k plus thrice k plus 0.2 plus k plus twice k plus 0.1 equal to 1. So implies that. So what we have here, if we add up all the k, 3 and 1 and again 1 and 2, so we have here 1, 3k, then we have k, then 2k, all this will give you, sorry, 7k is equal to 1 minus 1 minus 0.1 minus 0.2. So that gives you, implies that 7k equal to 7. So this implies 7k equal to 0.7. 0.7. So this implies k equal to 0.7 divided by 7 equal to 0. Now, given this, we now can define the probability mass function very nicely. It's taking 0, 1, 2, 3, and 4. And the corresponding values are probability of x equal to x, x equal to x equal to 0.1, 0.3, 0.2, 0.1, and then this is once again 0.3. So 0.2 plus 0.1, that is 0.3. So you have to check whether the sum total is equal to 1. 3 plus 1 is 4, 5, 6, 7, 8, 9, and 1. So this makes it complete probability equal to 1. So this is how we are sure that the value of k has been determined correctly. Now let us look at probability of second one, that is probability of x. Probability of x is greater than 2. So what are the values that are greater than 2? The values greater than 2 are x equal to 3 and x equal to 4. So probability x equal to 3 and probability of x equal to 4. So this adds up to x equal to 3 is 0.1, 0.1, and x equal to 4 at 0.3. So this probability comes out to be 0.4. Now we are to compute expectation of x. Very nice. It is obvious also because we are in the expectation of expectation chapter. Some stage we have to compute expectation of x. Write the formula summation of pi into xi equal to 0 into. So we'll use this distribution. This distribution we have deduced just now. This one, not the one here, because this is what we have found out. So 0 into 0.1 plus 1 into 0.3 plus 2 into 0.2 plus 3 into 0.1 plus 4 into 0.3. So this is equal to, first term gone, second term we get 0.3 plus third term we get 0.4. Next term we once again get 0.3 and the last term we get 1.2. So if you add them up, they will give you 2.2. So this is the expected value, 2.2. So this is the expected value of x. Lastly, we are to compute the variance of the term twice x minus 4. Using the variance formula we studied earlier. Now, if we know variance of x, then this is done. So, what is this? So, we are out to compute variance of. Now, variance of x is we know the computational formula, the expectation of x squared minus expectation of x whole squared. Now, these already expectation of x we have computed. What we require to compute expectation of x squared? So, expectation of x squared, let us write the formula first. Summation pi in xi squared. So, this is equal to, so pi is equal to 0.1 into 0 squared plus next here we have the probability density probability mass function given here, probability description given here. We will actually use those. From here we are reading the data. So probability is 0.1. So it's 0.1. And this is the corresponding development with 0 plus. Then we have 0.3. 0.3 multiplied by 1 square plus then probability of 0.2 multiplied by square plus probability of 0.1 multiplied by square plus probability 0.3 multiplied by 4 square. So these are the values. So we compute this. So this first one is not giving me anything because we have 0 in it. Second one we are getting 0.3. Next one is 4. 4 into 8 is 0.3. Next one is 9. 9 into 0.1 is 0.9. And then last one is 0.3 into 16. So 0.3 into 16, we are getting that as 48. So this is 4.2. So this is equal to the variance. If you add it up at that, 6.8. So the expression of x. From here, we use this particular expression. Right? This particular expression, we compute the variance of x. Reduce variance of x equal to expectation of x squared is 6.8 and expectation of x is 2.2. So that is 2.2 whole square. So this is ultimately giving me the value of 6.8 minus 2.2. So this is the value of 1.96. 1.96 variance of x. Now, to look at variance of 2x minus 4, already we know that this is 4 times of variance of x from this expression. So we are replacing them here, and now ultimately we have this equal to 4 into 1.96 is approximately 2, so it will be very close to 8. So if you multiply them in 100, we use 7.84. So this is how we reach the conclusions, how to find out the value of 2x minus 4. Now let us start this problem. Here we have x takes the value 0 or 1. It takes 1 with probability p and 0 with probability q equal to 1 minus p. Find the expression and the x. So it seems to be easier than what we have done so far. So let us start with writing the distribution. So it takes the value 0 with probability 1 minus. So probability of x equal to x is 1 minus 2. And it takes the value 1 probability. Okay, summation of the probability is equal to 1. Okay. Now we have to compute the expectation of x. So let us first write the formula. Equal to summation pi into psi. So this is equal to, we have 0 into 1 minus p plus 1 into p. So this is probabilities multiplied by the corresponding values of the random variables. So first expression does not mean anything. Second one is p. So this p. Now let us compute expression of x squared. So expression of x squared. So this is equal to formula is summation pi into xi square. So the first probability is 1 minus multiplied by 0 square plus second probability is 3 multiplied by 1 square. So this is equal to 1 3 this value. Oh, fine. Now let us look at what happens to the variance. So variance of x is equal to expectation of x squared minus expectation of x whole square. That means for proportional purpose, we use this formula where you see that. So expectation of x squared is p and expectation of x whole square is p squared. So if you take p common, you get 1 minus p. Either you can keep it in this way, but it is given in the question that 1 minus p is q. So you may write this. So expectation of x is p and variance of x is. Now let us move to illustration number 6. Here there is a box and in the box there are n tickets. The tickets are numbered serially from 1 to n. The box is shaken properly and then a ticket is drawn from it. The face value of the ticket is noted down. We have to find the expectation and variance of the face value. So there is a box and the box has as many as n tickets. So what we do is that we actually let us see what are the values in these tickets. So suppose the values in the tickets are my random variable. So the values are 1, then 2, then 3. Like this it goes up to n because there are total n tickets. Now these boxes shake properly and a ticket is drawn from it. It means that each of the ticket has equal chance of occurring. So what we have probability of x, this is same for all the tickets. That means first one is 1 by n, second one is 1 by n, third one is 1 by n, is 1 by n. So we have now to compute the expectation of x. So expected value of x, this is equal to 1 into 1 by n plus 2 into 1 by n plus plus n into 1 by n. So this is the expectation of this. So what I have, if I take 1 by n common, then we have within bracket 1 plus 2 plus up to, because up to n, up to n. Now, what happens? This is the sum of first and natural numbers. So, sum of first and natural numbers, there is a formula, and the formula is n into n plus 1 by 2. So, ultimately, n and n gets cancelled. So, we have this value as n plus 1 by 2. Next, let us look at, because they have asked us to compute the variance. Now, one step of computing the variance, we know that expectation of x square will help us to solve the variance. So, we come with expectation of x square, x square. So, let us write the formula first, that this is equal to summation of probabilities pi multiplied by xi square. That means square up of the values. So, first value is 1 by n multiplied by 1 square. Second value is 1 by n multiplied by 2 square plus plus last value is 1 by n multiplied by n square. So this is equal to, if I take 1 by n as common, then we have 1 square plus 2 square plus plus n square. So that is the first square of sum of the square of first n natural numbers. And then there is a formula for that. We have to remember the formula, and that is n into n plus 1 into twice n plus 1 by 6. So this is the formula for the sum of the squares of first and natural numbers. So this n and n gets cancelled. So we have n plus 1 into twice n plus 1, the whole thing divided by 6. Now let us look at the variance of x. So variance of x equal to expectation of x square, expectation of x square minus expectation of x whole square. Now expectation of x square, we have the value as n plus 1 divided by 2 n plus 1 by 6. This is expectation of x square. And then expectation of x whole square, that is we have n plus 1 whole square divided by 4. Now, here we can take this n plus 1 common. If we take n plus 1 common, then we have here just 1 minute. Then from the first part, from the first part, we get twice n plus 1 by 6. And from the second part, we get n plus 1 by 4. Here you see there is a opportunity of taking 2 also common. So when you take the LCM, you get this as n plus 1 by 2. And then this is, you take this as 6. So this is 2, 2 into twice n. It is, you get here 4n plus 2 multiplied by uh, thrice n minus 3. So this will give you equal to n plus 1 by 2 multiplied by, here you get n, and then you get minus 1, because 4n minus 3n gives you n, and 2 minus 3 gives you minus 1. So this is n minus 1 by 6. So ultimately you get n square minus 1 divided by 12. So this is the variance of this particular expression. Now let us move to the next problem. So here we have a problem. Here probability distribution is in front of us. It's quite clear. Let us look into the questions. What the question tells. A bakery has following schedule of birthday cakes demanded per day. So birthday cakes demanded per day. Find the expected number of cakes demanded. So you have to find the expectation only. But if you look at the data, here there is one twist, that it is number of cakes demanded in 100. So 0 means something less than 100. 1 means 100, 2 means 200. So this is expressed in terms of 100. So whatever be the probability, sorry, whatever be the expectation, we'll have to multiply it by 100 to get the exact number, if you speak about number, or else you keep it in terms of 100. Anyways, let us do this. So we have to compute the expectation. So we have the probability distribution before us, no need to write it. Let us write the formula. So this is pi into xi, that is given to you. So you have 0 into 0.02, that is probability 1, into 0.07, plus you have 2 into 0.09, plus 3 into 0.12, plus 4 into 0.2, plus 5 into 0.2, plus 6 into 0.18, plus 7 into 0.18, plus 8 into 0.01, plus 9 into 0.01. So you just multiply them and you just add them up, so that you get this number, and ultimately you will get this comes out to be 4.92. Okay, 4.92. So this is actually, if you want to see the details, so 0. This is not contributing anything. So we can have it also. This first term is not contributing anything. Second part is multiplied by 1. So it's same 0.07. Third part is 0.18. Fourth part is 0.36. Fifth part is 0.8. Fifth part is 5.02 is 1. And then the next part is 1.08. 6 into 18 plus 7 into 18. You will get it as 1.26. 1.26. Next part is 0.08 and the last part is 0.09. So ultimately, if you take the total of this, it comes out to be 4.9. So this is the value of your answer. Now, here this is 4.92 in terms of 100. That means if you express in terms of exact number, then you have to multiply it 4.92 into 100. That means they will get a demand of 492 cakes per day on an average. So this is the average number of cakes demanded per day. We proceed to the next problem. We have a problem of this type of problem. In this problem, what we have that this is a continuous random variable. That means this is a probability um, density function and not a probability mass function. So we don't have a probability distribution in front of us. Rather, we have a probability function. So first thing is that we have to find the value of k. Now look at the value of y. Random variable is y. Starts from 0. So we know that integration 0 to infinity f of y dy this is equal to 1. Now it implies that integration 0 to infinity k e to the power minus 5y dy is equal to 1. Based on this equation, we will actually solve it and we will find the value of k. Now we take k common e to the power minus 5y by minus 5. So this gives me the x value of the expression. Then we take this as 0 to infinity and then this is equal to 1. So this implies that these are all constant k and 5 minus 5 are constant. So but we need the value of k. So what we do is that we keep it like this. So we just now keep on putting the value. So e to the power minus 5 into y, there we put infinity. So e to the power minus infinity by minus 5, then minus of minus e to the power 0 by minus 5. So this is actually going to be, this is equal to 1. So this is equal to implies k to the power k into, so the 0, this minus and minus give you plus, e to the power 0 is 1. So this is ultimately give you 1 by 5. And so this 1 by 5 is equal to 1. So implies that k equal to 5. Now once you get this, then you get the complete density function. What is the probability density function now? Fy equal to k will be right 5 e to the power minus 5y and then y is greater than 0. So this is the complete probability density function we get, because henceforth for computing probability of y, expectation of y, variance of y, we will use this density function, updated density function with the value of k already in it. Now let us look at number 2 here. Okay. Now let us look at this expectation of y. So we have here expectation of y equal to integration of 0 to infinity y into density function. We just now did find out the value of k. So we have this equal to dy. Now here we can take the pull out 5 outside, and then what we have, integration 0 to infinity y e to the power minus 5y dy. Now this is a incomplete integral, which is a standard result. Let us see the result. What is the result? The result is that tells that integration from 0 to infinity x to the power n minus 1 e to the power minus, say, alpha x dx. This value will give me gamma n. Gamma n is actually factorial n minus 1 divided by alpha to the power n. So we will use that result here. Here in this case, x, in place of x we have y. So let us write 5 first, then try to understand. Then here you see, if you compare with this you have x to the power n minus 1. Here you have y to the power 1. Y to the power 1 is, let me write it in the same form, 0 to infinity y to the power. Now this is your 2 minus 1. And then you have e to the power minus, we have 5 and y dy. That means the same type of integral, only in place of n we have 2 and in place of alpha we have 5. So this will give me uh, equal to 5 into gamma 2 divided by alpha is my 5 to the power 2, 5 square, because here you see it is n minus 1. If you look at this equation, here you see n minus 1, then you have alpha to the power n. So here you have 2 minus 1, so here you have alpha to the power 2. Alpha is your 5. So that gives you gamma 2 is 1 factorial. So 1 factorial is 1. So you have 5 divided by 5 square. So that is 1 by 5. So this is 1 by 5. So expectation of y is equal to 1 by 5. Now let us compute the variance of y. But before computing the variance of y, you know that we need to compute expectation of y square. So that will help make my work easy. So let us delete this, make a clear space so that we can compute the expectation of y square. Because so expectation of y result, let us store it. That is expectation of y is equal to 1 by 5. Okay. So 1 by 5. Okay. Now let us start with computing of expectation of y square. Expectation of y square equal to integration y square. Integration starts from 0 to infinity, and then the probability function, that is 5 e to the power minus 5 y dy. Once again, we bring out 5 outside. So 5 is outside. And then we have take it to the form integration 0 to infinity y to the power, it's 3 minus 1 is 2, and then e to the power minus 5 into y, then we have dy. So this is equal to 5 into now this is a gamma integral once again. So according to that formula that we had placed earlier, we have like y this to the power n minus 1. So n is your 3. So we have gamma 3 divided by alpha. Alpha is your 5. So 5 to the power alpha. Alpha is once again 3. So this is equal to gamma 3. So this is the expression. This 1 by 5 is from the previous computation. So this is equal to 5 into, then 5 cube is there, and this is 2 factorial. So 2 factorial is 2 into 1 and divided by 5 cube. So one of these 5 will get cancelled. So this will become 5 square. So you have 2 into 1 is 2 divided by 25. So that is your expectation of y square. So you have variance of y as the formula comes out to be variance of y equal to expectation of y square minus expectation of y whole square. Okay. This is, you know, that for computational purpose, this is generally simplified formula which is used. So expectation of y square is equal to your 2 by 25. And then your expectation of y is 1 by 5. So this will give you 1 by 25 on square. So if you compute this, then you will get 25 divided by 2 minus 1 is 1. So 1 by 25. So that is the formula for variance of y. In case you are asked to compute the, okay, then compute the standard deviation of y. So you can have it like the standard deviation of y. This is the square root of variance, variance of y. So that comes out to be square root of 1 by 25. So square root of 1 is 1, square root of 25 is 5. So this is equal to 1 by 5. So you see standard deviation, mean, they are all coming to be 1 by 5 and they are same. So this is actually called as a uh, exponential distribution. And in exponential distribution, the mean and variance are same. Mean and standard deviation are same, which we have seen also indirectly without just through the integration, without going to the details of this particular distribution. Let us look into the last problem now. Here you see this is discrete or continuous. First tell me. This is a continuous distribution. Why continuous distribution? Because you see it is having different values, like discrete has different values. But the thing is that here we have this is for a continuous range of 0 to 1. it takes half value for a continuous range of 1 to 2, and the ranges of the random variable are continuous. It is starting from 0 going up to 3, but with a continuous break. Okay, so what is they have asked to find the mean of the distribution. Okay, now let us have this. We have f of x equal to already given to us. So mean of this. So we start the integration from 0 to 3. Why? Because the first value is 0 and going up to 3. But you see, we have to break the integration into parts. So this will give me 1. So if you are to compute the, so this is, you have to break the integration into parts, like from 0 to 1, 1 to 2, 2 to 3. So let us go and compute expectation of x. Expectation of x is equal to integration 0 to 3 x into fx into dx. So this is the formula for expectation. Yes. Now what we do, we use this formula 0 to 1, because the first part is 0 to 1, then x. And what is fx here? Fx here is x by 2. Okay. X will remain the same, but the function of the density function will change because it is differently defined in different parts. Then comes 1 to 2. Then what is the, this is x multiplied by, next one is 1 by 2. It is constant. This part probability is constant. And then we have this 2 to 3, and then we have x. And then this is 3 minus x by 2 dx. Okay. Now let us solve them one by one. So first one, what we have integration of x square by 2 dx, 0 to 1. Then last 1 to 2 x by 2 dx plus 2 to 3 thrice x minus x square by 2 dx. Okay, now you come here. Here what you do, here you take up half, here you take x cube by 3. Okay, that is the integration. Remember, the integration of x to the power n dx, the formula is x to the power n plus 1 divided by n plus 1. Plus c is a constant. In definite integral, we don't write this. So these are all definite integral because the integrations have some range. So, okay, now come to this part. So this is x3 by 3 plus, okay, this let us write the range of this. So it starts from 0, goes up to 1. Then we come here, so half comes outside, this is a constant, and x will become x square by 2. So half comes outside, x square by 2. We have the range of this is 1 to 2. Then we come to the third part. This part we have half, let us pull outside, and then thrice x will become 3x square by 2. Sorry, 3x square by 2. Half we have already pulled outside, minus this will become x cubed by 3. So bracket, and then this is equal to 2 to 3. 2 to 3. So now before we put the upper limit and the lower limit, let us simplify it further. So first one becomes x cubed by 3 into 2 is 6. So x cubed by 6, and then this is 0 to 1. Plus, then it becomes x square by 4. X square by 4, the range is from 1 to 2. And then plus, then this is thrice x square by 4 minus x cube by 3 into 2 is 6. And that one range is 3 and 2. Now what happens in the first part? We first put 1 and then put 0. Okay. We put here, this one. First we put 1 and then we put 0, and they are actually joined by a subtraction symbol in between. That means we find the difference of this, difference of the upper limit. So when you put the upper limit 1, you get 1 by 6, minus when you put 0, you got 0 by 6. Okay. Plus when you put 2, you get 2 square, that is 4 by 4, minus then you put 1, that is 1 by 4. Plus, now next part, when you put 3, you get 3 square is 9. 9 into 3 is 27. 27 by 4 minus, and then you put 3 once again. So 3 cube is 27, 27 by 6. Okay. Now minus sign comes in and first term becomes, when you put 2, 3 into 2, 2 square is 4. So 3 into 4, 4 3s are 12. So this is 12, denominator is 4. Minus and minus, this one will become plus. Plus here you put 2, so 2 cube is 8, 8 by 6. Okay, so this is the entire thing. Now first term, you see, this is equal to, sorry, this is equal to first term 1 by 6, because the second part is 0. Uh, and then you come to this part, plus x for 4 by 4 is 1, 1 minus 1 by 4. Okay, plus these, if you take LCM, then it is better. So you take the LCM. LCM will be, I think, 20, 12 is the LCM. 12 is the LCM. So first is 27 into 3, because 4 3s are 12. So 27 into 3. So 27 into 3, I think it's 81. 81 minus second part, 27 into 2. 27 into 2 is 54. Then minus third part is actually multiplied by, denominator is multiplied by 3 to reach 12. So 12 is also multiplied by 3. So that gives you 36. And last part is multiplied by 2 to reach 12. So 8 is multiplied by 2. So that is 16. So this is what you get. So ultimately you get this as you get 1 by 6, 1 by 6 plus 3 by 4 plus 7 by 12. Because if you add this up, 81 plus 16 minus 54 plus 36, that will give you 7 by 12. So ultimately, once you again you take the LCM, so your denominator is 12. This is 2, and then 3 into 3 is 9 plus 7. So this is equal to 18 by 12. That is 1.5. 18 by 12. It is equal to 1.5. So this is the average of this particular probability density function, which is divided into parts. That means we don't have the same function throughout, but within the range we have some partitions where the probability density function acts different. So with this, we come to an end of this video. In this video, we have solved different problems related to random variable and mathematical expectation for both discrete as well as continuous random variable, that is both for PMF and PDF. Thank you for watching this video. Stay tuned in our channel. We will come up with more such videos. Thanks a lot.